Yeah, you can start. This is Uganda Online Lessons, and once again, Coach Seranja Shakif. Please like and subscribe to our Facebook and YouTube channels. Share and give us your feedback. Thank you for watching. Today we are going to look at trigonometry of O level. Let's try to write our heading here. Trigonometry. In trigonometry, we are gonna look at what we call right angled triangle. In right angled triangle, we are gonna specifically look at what we call Pythagoras theorem. Another, what we call ratios of sides of a right angled triangle. And another, we'll look at what we call quadrants and revolutions. Then after, we look at what we call non-right angled triangle. And here we are gonna study about what we call sine rule and cosine rule. Then after, we look at what we call area of a triangle. Finally, and we look at what we call Heron's formula. Those are major topics we are gonna look at trigonometry. So let's start our topic briefly. The word tri means three. So trigonometry is simply the study of geometry of a three-sided figure which is called a triangle. And then after, let's look at what we call naming of a triangle. In naming a triangle, we undergo what we call Euler's notation. and it looks like this. If we draw our triangle here and we name this one angle A, this one angle B, and this one angle C. So this side down will reflect C, and this side also reflect A, and this side will reflect B. So this is what we call Euler's notation. So let's go to what we call a right angled triangle. A right angled triangle is the one which comprises of a 90-degree at its base. If this is A, B, C, so this side will reflect B, and this one reflects A, and this one C. So this side is the one which is called the hypotenuse. This one here. So the Pythagoras theorem states like this: side AC squared will be equaling to the sum of squares of sides AB and BC, which will be side AB squared plus side BC squared, which AC is B squared, equaling to AC AB, which is C squared plus BC becoming A squared, in finding B alone to be square root of C squared plus A squared. That's what we call Pythagoras theorem. So this side AC squared will be equaling to the sum of squares AB squared plus BC squared. So AC is this side which is B, and AB is the side which is C, and BC is the square which is A squared. But in finding B alone, we shall then square root the what? The right hand side becoming root of C squared plus A squared. So let's try to look at an example here. Given that angle triangle PQR is right angled at Q and QR equaling to 3 centimeters, PQ equaling to 4 centimeters. Try to find length PR. So let's draw our right angled triangle, which looks like this. They say that it is right angled at Q, meaning Q is here, R becoming here, and P coming here. They say that QR is 3 centimeters and PQ becoming 4 centimeters. They want us to find PR here. So by applying Pythagoras theorem, it will be PR squared equaling to PQ squared plus QR squared coming PR squared, applying the figures, coming 4 squared plus 3 squared becoming PR squared coming, this is 16 plus 9, and P becoming 25, applying a square root on the right hand side, to 25, PR becoming 5 centimeters, and we have come up with the side PR equaling to 5 centimeters. So then let's try to look at what we call ratios of sides of a right angled triangle. Ratios of sides of a right angled triangle. So if we have our right triangle here, right angled triangle here, naming this angle theta, and we name this one A, this one B, and this one C. So this side will be what we call the hypotenuse. This one becoming the opposite, and this one becoming the adjacent. So in ratios of a triangle, we shall have a ratio which is called opposite over hypotenuse, which is equaling to sine theta. We have another one which is called the adjacent over hypotenuse, which is called cos theta, and another one being the opposite over adjacent, being equaling to tan theta. So in trigonometry specifically, we are gonna consider only these three ratios. This one becoming sine of an angle, and this one being cosine of an angle, and this one also becoming tangent of an angle. For easy memorization, we shall take this simple formula, which is called SOHCAHTOA, meaning that sine of any angle is equaling to opposite over hypotenuse, and another one being cosine of an angle equaling to adjacent over hypotenuse, and another one tangent of an angle being opposite over adjacent. So let's try to look at one example here concerning with ratios of a right angled triangle. It will be in a triangle ABC, angle B is equaling to 35 degrees, and angle A equaling to 90 degrees, and line BC equaling to 8 centimeter. They have told us to find line SC. So let's try to draw our right angled triangle, being here 90, but they have told us A equal to 90, so means here there is A, B equaling to 35, and this one also becoming C. They have told us BC is 8 centimeter. They have told us to find this one. So when we try to look at SC, it is called the opposite, and they have given us the hypotenuse. So if we try to find out which ratio can fit there, we are saying that a sine ratio can fit there, becoming sine of theta, which is 35, sine 35, equal to opposite, which is AC, over the hypotenuse, which is 8. So line AC will be equal to 8 times sine 35 degrees, and line AC equal to 8. If we get sine 35, it will be equaling to 0.5736, and line AC equaling to 4.588, and if we round off, we shall get AC equaling to 4.6 centimeter. After that, we are gonna look at one example from each of these ratios, and we can get a complex question like this, which will say that a ship travels for 10 kilometers on a bearing of 120 degrees, and then 5 kilometers on a bearing of 270 degrees. So how far south of its starting point does it finish? So let's try to sketch the journey. They have told us a ship travels for 10 kilometers on a bearing of 120. So we shall have our compass here, coming north, on a bearing of 120 degrees. So we shall approximate 120 degrees to be around here. Let me say from here to here is 10 kilometers, and we draw our compass again here. This is north, and they have told us, and then 5 kilometers on a bearing of 270. So which is here, the 270 being here. Let me say here is the 5 kilometers. It's stopped here. It's stopped here, but they have told us how far south of its starting point does it finish? So here is its south of a starting point. So they have told us to find this distance here, from here up to here. This is the required distance. So being 120 here, so means here this is 30 degrees. The same here, 30 degrees. So by looking here, we have got the hypotenuse, and they want what the opposite, because this is a 90 degrees here. So we shall use what we call a sine ratio, becoming sine theta, which is 30, equal. So let's name this side A, being equal to A over 10 kilometer, which is the hypotenuse. So A will be equaling to 10 times sine 30, and A will be equal to 10 times a half, which is equal to sine 30. A equal to 5 kilometer. So here is 5 kilometer south of its finishing point. So let's also try to look at another example from a different ratio, which will look like this. In a triangle ABC, BC is equaling to 6 centimeter, and SC is equaling to 12 centimeter, and angle B is equal to 90 degrees. Find angle C. So let's try to look at this question here. They have said that B is equaling to 90 degrees. This one becoming A, then becoming C. And they have told us that BC is 6 centimeter and SC is 12 centimeter. So they have told us to find this angle. So let's name it theta. So they have given us the adjacent and the hypotenuse. By going to our ratios, we see here adjacent and the hypotenuse equal to cosine of an angle. So we shall bring it here, adjacent over hypotenuse equal to cos theta. So let's try to substitute. 6 over 12 equaling to cos theta. We shall get a half here equaling to cos theta. But they want us to find this theta. So we shall say theta is gonna equal to cos inverse into a half, and if we get cos inverse of a half, it will be equaling to 60 degrees. If you place your calculator, you get 60 degrees. Let's also try to look at an example from a tan ratio. It's saying a boy stands 150 centimeter from the foot of a tall building. He estimates the angle of elevation of a building to be 30 degrees. And it tells us what is the height of a building. So let's try to sketch it here. Let's say this is a building. This is a building, and they say that a boy stands 150 centimeter, meaning this is its foot here. It's standing 150 centimeter from its foot and estimating an angle of elevation to be 30. Means to be 30 degrees. The boy is here, and they have told us to find what is the height of a building, which is here, which is the opposite, because this is a 90 degrees. So let's try to name it X, and if we go to our ratios, we shall look at which ratio consists of opposite and the adjacent side, which is here, opposite and the adjacent side, which is the tangent of an angle, being opposite over adjacent equaling to tan theta. It will be opposite, we named it x, over adjacent, which is 1 pivot equaling to tan 30 degrees, which is the theta, meaning x will be equaling to 1 pivot times tan 30 degrees. And if we calculate tan 50 will be tan 30 will be equaling to 0.5774, getting our x equaling to 86.95 centimeter. So the building is 86.95 centimeters tall. So after that, we are gonna look at what we call quadrants and revolutions. Quadrants and revolutions. So if a person turns through an angle of 360 degrees, he or she is said to have made what we call a revolution. So it will be 0 up to 360 degrees. So it has made a full revolution. So if she or he makes another one to be equaling to 720 degrees, and another one equaling to 108 degrees. So this one will be first revolution, this one becoming the second revolution, another one being the third revolution. But for our syllabus, we are gonna consider only this first one. And the first revolution, we are going to look at what we call quadrants. So let's look at what we call the Cartesian plane. It looks like this. We name them anti-clockwise. So it will be here 90, 90, 90, 90. So this angle here is between 0 degrees, this is not equal to theta, equal to 90 degrees, which is on the first quadrant. And this one being 90 degrees less or equal to theta, theta is less or equal to 180 degrees, being the second quadrant. And this one, the big 180 degrees less or equal to and less or equal to 270 degrees, being the third quadrant. With 70 degrees less or equal to theta and less or equal to 360 degrees, and this becoming the fourth quadrant. So here, after this, we and is that one of one demonstrate for you like this. So first quadrant, we have